Alright, hello. So here I want to show you with the PicoScope 5000 using the ability to dynamically adjust your resolution. So to do this, I'm going to use an application that might be fairly typical. So I have a switching power supply here, and I want to see how it responds to going from almost no load to close to full load. So to do that, I have this bank of resistors here, and I can switch on any of the resistors. So there's a 3.3, 2.5, and 1.2 volt supply, and the resistors are set up to give me about 2 and 2 amps, and then on the larger, the 1.2 volt supply, it goes up to almost 6 amps. So I know these wires are a little flimsy, but it's just a quick test. So for example, you can see here's the input power supply. So when I turn on the close to 6 amp load, the 5 volt input goes to about 1.5 volts. And similarly, if I turn on the other supplies, you can see that current go up here. So let me turn this off, and what I'm going to be monitoring, I'm just looking at the 1.2 volt supply on the PicoScope probe here. Turn that off here. So here's sort of your typical setup that you might have with any scope. So the first thing I'm going to do is just look at how the signal looks. So we're at 1.2 volts here, and then I turn on the load and see what happens. So we're actually seeing some pretty bad responses here. We see these huge negative spikes going down much more than we'd like. So that might be the first thing we do. The next thing is probably to see, we're interested in what happens when it turns on and off. So to do that, I've pulled the trigger down to about where that happens, and I'll set this to single mode. So on, and then when it goes off, this is where we see this even bigger positive spike. So we might be wondering how big it is. So I'm going to switch this to rising edge, and we'll just replay that again. So here's where we run into an issue. The spike is going beyond the 2 volt input range. And this is why, even though you might say, well, 8 bits is enough, it's really handy to have the ability to switch into higher resolution, because now I've had to switch to this plus minus 5 volt range because there is a little spike, but I'm also interested in the details here. So let's do that again. Okay, so now we can see the actual limit of the spike, although it's quite short, so it may go a little higher than that. But the problem is that because we have such a small range, our 8-bit resolution on the scope isn't as useful anymore. So what you can do is actually switch with the PicoScope. So it's switching the ADC resolution to be much higher now. When we do the same thing, all of a sudden we're getting far more detail. So the only downside is here we've switched down to a lower sampling rate. So you can sort of play with the trade-offs here. And let's see, so here we're slightly higher sampling rate still. Okay, there we go. So now we're back to a high enough sampling rate, but we have a 12-bit resolution, which is still much better. So when we zoom in, we can still see a lot more detail in here. By comparison with the 8-bit side, if I just recapture, we don't see nearly as much detail. One thing you might see is that I think almost all scopes have a resolution enhancement mode, which basically uses filtering to increase the number of bits. It's important to realize that this does help somewhat. So here, for example, I go to 10 bits, and you can see that it looks like I'm getting more detail, but you have to be very careful with this because it can also affect your signal. So for example, if I just crank this up to 12 bits with resolution enhancement, not the actual ADC resolution, you're losing all the detail of those spikes entirely, even though you think you're sampling at a really high rate. So you have to be very, very careful using that sort of software resolution enhancement. And it's quite nice on the PicoScope devices that you can increase it by half a bit at a time, so you can actually see intuitively the effect of that. Of course, if you have the 5000 series, then you can just increase the actual bit resolution that we're capturing at. That sort of also solves the issue completely. So going back to the original problem, so here's when we go from full load to no load. and if we play around with the triggering, we should be able to get the other way, which is from no load to full load. So there you go. And again, I'm using a really wide, plus minus 5 volts, which the 8-bit resolution would have been okay if I didn't need to use such a wide input range. If I only needed to use the 500 millivolt range or 100 millivolt range, maybe that would have been fine. But if I want to be able to capture all the detail of that spike at the output going up to 5 volts in the same capture setup, then having the ability to switch the bits instead is very convenient.